So what I'm going to present today is my personal journey on liquidity research that started almost 10 years ago, and in particular the journey in BlackRock, where I started to run this project 3 years ago. And the topic of liquidity is a typical financial problem that is very difficult to solve. That's why the papers and research in liquidity, they arrive pretty late in the industry and in the standard methodology. And because of sparse data, because of or sparse or noisy data or multidimensionality. So it's typical type of problem where machine learning can help. Okay? So what I'm going to show to you is, first of all, what is the AI for us. So what I think is the right usage for us in finance, in particular for my specific project of machine learning AI, why and when in finance, in particular in liquidity, the problem of hunting for performance, but be aware about black boxes. And I will present some model, overview on the model we already implemented, and give you a tour of the lab models that we are testing in the lab. Okay? So, a little bit of names. So, for me, machine learning is making sense of a large data set, recognizing complex pattern in the data, and is be able to account for non-linearity and get rid of other mathematical assumptions, like assuming linearity of some behavior, some features, or normality, all this kind of stuff. The typical mathematical assumptions that were done in what I call quant finance 1.0. To me, machine learning, I prefer to use the word machine learning than AI. So far, my machine is not intelligent. It's just a machine that can crunch a lot of data and extracting patterns in those data. And some of these patterns, behavior, are good for me as features in the job of forecasting liquidity in our security level, portfolio level, redemption at risk, whatever we do. Okay? There are some cool names here. These are the ones dear to me because I started many years ago to leveraging a lot of cluster analysis in this type of problem. Pattern recognition is what they say. Regression, because now everybody are ashamed to say regression. No, we still use regression. And I'm not ashamed that last quarter we rolled out 3 models in production, 2 based on machine learning approaches, and 1 was a linear regression with 2 variables, does its job, no shame in doing that, okay? So I am a guy looking for innovation. I am dreaming to be able to build for liquidity the first serious deep learning model. Interpretability is another problem I'm going to mention to you, but if you have something that does its job and is a simple interpretable model, 2 variables in regression, take it, okay? Now, machine learning is not that one. So it's not a robot, in particular in finance. Think about finance, we have a fiduciary role to our clients. So I'm building model, providing analytics to portfolio manager or a trader, and this guy is making business decisions with other people's money. Okay? So we cannot use black boxes, things that we cannot understand. So for me, machine learning is not is a Casimo scenario, maybe one day, but not now. And there will be enough old in that day when it's going to happen. And when you recognize pattern in financial data, you can recognize that pattern. So there is a correlation between the interest rates and the age of the Fed chair. So you know better than me that if you plug these features in a machine, whatever is regression, this will be significant features. So now you pretend to know the next age of the Fed chair, you are claiming to forecast interest rates. So you must be careful about this type of pattern that the machine will include. In particular, machine, in the case of deep learning, will use this pattern without telling to you. Okay? Just to set up the stage, right way in the middle between myth and reality of application of machine learning in finance. Explainable AI, XAI. People love acronym. This is a new acronym that's, I started to see this acronym a few years ago. And we must enable the user to understand what the algorithms does. So basically, this is a beautiful chart extracted by a presentation done by DARPA, but it's beautiful to represent the function between explainability and the learning performance. So clearly, we are now moving, in particular in our case, in this area. The dream is to go to deep learning, but we still have something to do before going to deep learning. But for sure, we are able to prove that traditional old machine learning methodology, if we call random forest machine learning, and they do, can add important improved performance, in particular now that we have a lot of data to train the model. Okay, so this picture is our guidelines for our daily job. When we do in the lab, we try to push on innovation. Okay, so our journey on machine learning applied to liquidity. And again, I was, a few years ago when I started to work on liquidity, people in finance here know better than me, in particular people who are working on fixed income, that in particular 10 years ago, there were no data. Okay? Trace was a system where trades data were reported for US corporate bond, highly noisy, not completely transparent, with caps, etc. And there was nothing in Europe, almost nothing in Europe, nothing in emerging markets. Equity, you had a lot of data, but highly noisy, and there wasn't a practice about model to forecast the liquidity of a security. So you have a situation where we have a lot of data highly noisy, so you need to extract signal from this ensemble of noisy data, or you have entire market where you have a decent amount of data only on a small part of the market, and it come out with a forecast for the rest of the security in the market. So the principle here, every trader, every portfolio manager will do exactly, taking a bond, for example, putting the bond in Excel, start to put in Excel some features downloaded by information provider. Then, based on his experience, we start to define the list of similar bonds based on some features, rating, coupon, amount of standing, etc., and trying to back up, have a sense of price and the liquidity of the target bond is trying to evaluate, looking similar bonds. The beautiful thing of machine learning, cluster analysis, random forest, basically more or less do that thing, and you can scale and automatize that thing. Okay? So that one, I think, was the first adventure. Now, what we do here, this is the description of the entire overall project. So because of this problem of estimating liquidity arrived very late. And liquidity arrived, if you look best practice for a credit model, default probability model. We can agree or not agree with those models, but there are plenty of models from the 80s. Deep mathematical model, very complex model. In liquidity, there is almost nothing. A couple of papers almost playing with the same three concepts back and forth. Exactly because no data, etc. And so people was keeping liquidity a little bit outside the risk management process. I do market risk, I do credit risk, I do portfolio optimization, I do tracking error, and then on the side, I try to figure it out to have a sense what is liquidity in my portfolios. Now, regulators gave me a job, because regulators 10 years ago, on the buy side and on the sell side first, then on the buy side, they start to push for people to adopt liquidity measurement metrics to control liquidity risk. In particular, BlackRock decided to have a more broader vision, so really embedded liquidity in the risk management process. Many years ago, when I was trying to convince my former company to invest in this type of research, I was mentioning, you should think about value to risk, widely used by everybody since 30 years, maybe 25 years. Is not necessarily the right risk measurement, but create a baseline out of which compliance people, portfolio manager, risk manager talk based on some numbers, okay? I want to digress how good or bad is value to risk, but value to risk create this link. And if you think embedded in value to risk, there is one crazy assumption, that you have historical series of the price out of which you generate your distribution. So every single position in the price 20 days ago, you could have sold that day your entire position immediately in the market at that price. That's simply not true. Because when you want to unwind the position, then you need to decide the venue, decide how you want to sell this position. If the position is big, you're going to have a cost. Okay? So a lot of people start to become with the concept about liquidity adjusted value to risk. Okay? So this was a way to plug liquidity from the beginning into the risk management process. So what we have to do? We have to do a gigantic infrastructure. Unfortunately for my job, every company I went, I was hired to build models. I started to build models after 18 months, 24 months. The first 3 years was building databases, cleaning the data, going around the company and hunting for data. If the data weren't there, convincing the big guys to have funding for the data, pulling the data together. So it was necessary to create this environment. This is exactly what we did here. So for liquidity, there was a necessity to unify the data we already were having, internal data from BlackRock, external vendor, purchase other external information, crunching this with high-performance computing. In this case, we use a lot of GPUs. We create our research environment, and where necessary, based on machine learning. This, we call this actually our liquidity vault. Okay, we have all this magic data to build the liquidity models. Then we go here, and the first job, we want to build transaction cost. We want to simulate that because of portfolio optimization, rebalancing, whatever, we want to sell a specific volume of a disposition, can be a bond, an equity, whatever. We want to have an idea how much it's going to cost us. And if we wait more time or less time, how the price is going to change. So we want to build this liquidity transaction cost surface. Then we want to aggregate the portfolio portfolio level, the liquidity, and this is tricky because the concept of correlation of liquidity, the typical way people they aggregate the portfolio level, is trickier. And if you start to sell a bond in a portfolio, and you have bond the same issue in the same portfolio, when you go to sell the second bond, maybe the liquidity profile of this bond is changed because of the first sell you did. So here, I think there is a better way to approach this problem. I'm going to mention to you. Then the other side of liquidity, that for asset manager is very important. Assuming that my portfolio are liquid or I'm in control of liquidity, I can receive redemption from my clients on the fund. So I need to be able to unwind the position at reasonable cost because I'm controlling liquidity risk, to give it cash back to the people that are redeeming the fund and not to hurt the people staying in the fund. Okay? So I discovered that redemption at risk is one of the most difficult problems ever, because thinking of being able to forecast that in this particular fund I will have these outflows next week or next month is a very difficult problem, because it depends from market conditions, specific idiosyncratic information of the fund, behavior of people. Depends from if the fund is widely used for pension fund for other company. If there is a moment where a lot of people will retire, we're going to have structural outflows in the fund. So there is so many things to account in the fund. So basically, here is the case where we try to clean the message with linear regression, gradient boosting machine, lasso regression, but the only way where we found some decent performance was using neural networks. Okay? Then we plug this. So the liquidity analytics as built at the beginning. We plug this into portfolio optimization, and our dream is to arrive to this concept where we have, this is the portfolio. Actually, it's a chart, but it's a real simulation, a real fund, where you have cash, the cost, and you want to allow a tracking error. If you want to sell pro rata or allow the portfolio to optimize the liquidity profile, and you want to basically to control the risk. So basically try to have the highest possible cash raise with the lower possible cost. So you want to try to be in this area of the curve. Okay? And then when you have this, you can finally make everybody happy. You serve with one centralized engine, portfolio construction, trading support, liquidity adjusted risk, what I mentioned before, and regulatory reporting. Okay? And we are, for some things, we are in a good stage of the project to serve these guys. We are still working for the coverage in order to implement, to plug into this optimizer in our platform. Okay? But this will give you a sense of the broader project that we are doing on liquidity. To honor my guests, so the Google people that kindly invite me here, give you a sense of what we are doing here. We are using the cloud. We were the first user in BlackRock, my team, of the Google Cloud. There are many other people using the cloud now, but we are basically using the cloud for proof of concept, and that's where I found the benefit. So I have a couple of guys, very expert in machine learning, but they have their job, liquidity. My job is not building neural network. My job is providing liquidity analytics. So sometimes we don't have the bandwidth to do experiment. And having this guy be able to experiment and bringing up to 40 plus GPUs to train a neural network, or using the iCPU's instance with the 96 cores that were available, enable us to speed up our POC process, flag an idea as a bad idea, so saving time, or actually start to investing on this idea. Okay? Now, this is the role of machine learning in our research. I try to, so the problem that we attack machine learning, first of all, we are doing ML on small, on medium data set for a moment. We are expanding now to large data set. And I'm mentioning this because you will not see here deep learning model. Because by definition, to do deep learning, you need to have a massive data set, okay? So here we are working with small and medium data set. Based on for transaction cost, redemption at risk, tradable volume, actually was our big successful story of last year. So to one component transaction cost, must be able to forecast the T+1 tradable volume of specific QZIP. And we found a lot of benefit in the model leveraging machine learning. And security similarity, the concept I'm going to introduce. Machine learning tools we use, primary regularized linear regression, random forest, Gaussian Bayesian trees. Despite in the lab, we have a neural network implementation of some of this model. Number 4, the usual suspects. So the the neural network implementation, despite they are improving the performance with respect to the random forest, but not crazy because the data set is still medium size, we have the problem of interpretability. So we prefer for a moment to roll out a random forest approach and respect to the neural network, where we are keeping this in the lab, we are still researching on this. I will try, as you know, synthesis is not the best quality of Italian, so I talk a lot, but I will try to save 5 minutes for Q&A at the end. Now here, I'm drawing to see how typical the problem we need to solve. Bid and ask spread, straight line. Useless, because tell to you that you have the same cost independently from how much you want to sell. The theory is every transaction cost model in every paper, more or less, is using a sublinear approach, in this, the typical square root function, or you can spend hours to recalibrate the exponent 0.6, 0.4, but this is the approach. Those models are very poor because the blue points are more or less how the data will look like. Very noisy, but actually the cost goes down for when you trade super small volume. Then it's almost flat around the bid and spread. Then we start to spike up. And when it spikes up, typically you don't have a lot of observation. I'm talking about 3-4 observations per bond in a quarter. So how can you fit a model in that area? So the real curve is the green one. The theory says try to calibrate the model using the red one. And now we think that neural network approach, deep learning, we can help a lot in the future to actually go in non-parametric and going to fit much better and forecast much better this curve, okay? There is typically the 3D problem, so I want to have a model that together can account for the slippage of the curve in function of time. So now if I have a cost of 10 basis points, selling 10 million, if I wait more time, I will be able to lower the cost. So that's the 3D problem people are trying to solve. And the similarity concept is very important because it's something that you must account when you build liquidity models. Bond 1, bond 2, assuming that this is the good curve. Stay with me now. I'm selling something in bond 1. eventually I'm gonna shift the curve of bond shoe. So when I'm gonna go to sell the bond shoe, I have a different transaction cost curve. And this, to us, can be attacked, this problem, using security similarity, making a linkage between securities. Google has the knowledge graph, a similar concept about this, making a link between entities, in this case, security in general or bonds. Now, the data. First of all, let me go back. This whatever equation curve you use, you have observed cost, and you are aiming to train a model based on this cost. Okay? People coming from other sector, that's why I asked the question before, they think, okay, I have an historical series of something that I observe, that's the Bible, that's true, and now I can train my model, whatever model it is. In finance, I'm sorry, the situation is not like this. To provoke you understanding this concept, here I did. This is my transaction cost curve in function of volume, traded, bid and ask spread, average daily volume, and other features. The dependent variable is this called implementation shortfall. Is the differential between a trade that I did and the benchmark price. So the market was at this level, I traded this level or this level. This differential is the cost that I got in the moment. I look the cost, I train the model, and try to forecast in the future this cost, okay? Here is a very liquid bond, very easy. It's a telecommunication bond, between 3-4% coupon, maturity 2022, and they calculate this implementation shortfall with our trades versus 3 different information providers. Everybody claiming, I give you the right price. Okay? Look the 3 curves. So now you train whatever it is, linear regression on our network. When you are here, you are in trouble because you don't know even which is the truth. So I tell to my guys, I'm sorry guys, but 60% of your job is plumbing and cleaning data. This is something that we have to do internally. That's why the application of machine learning in finance, there are many reasons, but the fact that we are dealing with real money, but as well this type of problem. Data to train the models are often not available, or now that becoming available can be very noisy, very inconsistent. Okay? Now, what we do here, this was the implementation shortfall that I mentioned before. So we have our benchmark price, we execute a trade, the differential is our observed cost, out of which we train our model, whatever methodology we use. And our model is defined on many important features. Fixed cost, typically the bid and ask spread. The volume forecast. I know that this bond has high-level tradable volume. Whatever I want to sell, I have a lower cost. A bond with lower tradable volume in the market, if I grow closer to this level, I'm going to have a spike of the cost. And other features. And I show this diagram because for a moment, instead of going wild in deep learning or this kind of stuff with the entire transaction cost, we only for one component of the transaction cost, we use machine learning. And now we are attacking the other part, okay? And here we use random forest. We have an implementation in the lab with our network with the same problem, interpretability. And this is very important because this model now is in production. It works very well. So far, our customers, the traders, are very happy. The problem that, think about, let's assume that I have the perfect model. I don't, by the way, but I have a decent performance. Tomorrow, I forecast for a specific bond a big drop in tradable volume. So it's a signal, very severe warning for our traders. They need to do something about that, or not kind of quarantine the bond if they have to unwind some position, not that one, or start to sell. To implement a strategy to hedge us from this liquidity risk on this bond. If I say there is a drop of 50% of the tradable volume, it's a big thing. Next thing, the guy will going to ask me, why? And I cannot tell to him, I have a beautiful deep learning model, I backtest it, I'm cool, my guys are smart computer science people, take it. Because this guy is making decision, trading real people money, okay? That's why in our network, we can back up some sort of interpretability, in random forest. we can become some sort of interpretability. Now I can say to the guy, I have an example here, why the model is moving, is forecasting something different. So only on the volume forecast we have this framework where we apply neural network, and we basically, now I don't want to enter too much in details, happy to provide you offline some details, but here what we do here, we train two random forests, one on empirical data, using empirical volume data, and another one based on features in absence of transactional data. So we are able to leveraging to have a guess of the tradable volume for bond that never show volume. A bond that never show volume, for example, doesn't mean that it's in liquid. It's a bond that doesn't show trade, but you can go to trade this bond easily, or is a signal that this bond is untradable, okay? And then we have some concept of probability of trade. So we separate the model in trying to define the probability, how is the probability that this bond is going to trade, and then when it's going to trade, which is the expected volume, okay? And this model so far is working pretty well, and is the one that has a neural network parallel approach on this. Transaction cost overall, I tell you the sad story of the progress of this model. This is very important. So we have initial model, linear regression model based on end-of-day data. The crosses means very poor auto-sample performance. I can tell you, only between us, that the auto-sample performance of this model was 1%. So pretty low. And the reason why I'm putting these dots and not the numbers, because some people in my company, they warn me, listen, you're going in front of Google people, and there will be a lot of non-financial people. And then you're going to brag the performance on the last line, that in finance is a very big number. Outside finance is a ridiculous number, okay? Or not ridiculous, but low number. So just to avoid the credibility issues with you, I hide the number. So I build the scoring, no? So the first one was very bad. When I went to intraday data, I did some work on defining better the implementation shortfall that I mentioned before. The model was okay. Then we start to do partitioning on the universe, so we start to separate buy and sell. Then we start to separate, if you think we start to do a concept of manual clustering. So we are bucketing the universe in more homogeneous groups and fitting the model within each groups. And if you think is what in one shot a random forest will do. And now we are working a lot on generalized additive model, non-parametric model like random forest, and we are as well in the lab testing neural network. This is neural network for the entire transaction cost, so not only one component. We expect that if we train the model of a big amount of data, the performance will be very high. I don't know yet. Next event, you will know how the model works. So far, we roll out in production this model based on an aggressive approach, based on partitioning of the universe. Now we are generalizing this with cluster analysis and random forest. That's our next step. But so far, we roll out in production this model that is using the ADV based on random forest, and so far the model performed pretty well. Okay? Give you some story of the evolution of our experiment. This is an example of November 2000. Okay, my company was very lucky not having in the last 4 years any serious liquidity stress. For me, it was a damnation because I have nothing to train the data on liquidity stress. Okay, so I say this against the interest of my company now. I needed some bad moment so I can verify my model. Otherwise, everything is good. My model is good. Something like this happened in November. There was some stress in the market, in particular in the corporate bond market. And we are very happy to see that from beginning of November up to Thanksgiving, where the stress was very evident and manifest, there was a situation, that's why we have a job, situation where portfolio manager, they were ordering, okay, I need to unwind this position. That's fine, because bid and spread is not moving. And the traders say, I'm sorry, but when I go to trade these guys, it's more difficult. I have an higher cost. And there was this connection between the two. The concept of liquidity doesn't depend necessarily of observable bid and spread, can depend from many other features. So the entire model, we are able, this is something that you cannot do in neural network. So I was invited yesterday in the AI Spotlight, Google, to find a solution. This is something that you can do with random forest. This is the evolution for a group of 3 bonds in the issuer average behavior of the transaction cost across November. And the transaction cost went up a lot in terms of basis point. So what we could unwind here were very different from what we could unwind at the end of the month. And you see that duration time spread was spiking up as expected. Linear spread is almost flat. Linear spread in that month actually went down, even counterintuitive, of 0.2 basis points, so nothing. Okay? But ADV was dropping, and interestingly, the number of dealer runs was dropping. So one of the features we use is just simply count how many dealer runs are contributing this bond. It's a measure of interest. I know that if there are some Google people here, they're going to have a lot of ideas about leveraging use and stuff like this. But for a moment, for us, counting how many dealer runs are contributing a bond is an indication of interest around this bond, in making business around this bond. Now, this number drops. For us, is a warning. The model reacts to this. So bid-ask spread, that is technically the main driver of transaction cost, wasn't moving, but other features, less important, a lot of them, they were moving, and finally, the transaction cost were doing a good job. I did my test. I claimed the model worked. Now I don't want any more stress in the market because it was a very painful month for me. Anyway, but this is exactly the reason why we are doing this job. So now we can provide a signal ex ante to the traders, and we can attribute this to the import features. Okay, idea for next step. Very quick. I mentioned to you that we have in the lab generalized additive models that we try, and for this different group of market, we improve the performance of the model of 6, 22, and 11%. And that's very natural. It's kind of fitting a sublinear model, different model for every band of volumes. So it's the orange curve. If you remember, it's exactly similar to the empirical shape of the data in the first slide I showed to you. Going down, then up. Then one thing my guys will start soon in the lab is leveraging reinforcement learning on the transaction cost level. And this we think is going to be performing very, very well technically, and particularly useful for stress testing. I have nothing to say to you now because we need to start. We are configuring the environment to do this experiment. But this is an evolution of the transaction cost we're going to do. Similarity. This is I've been bragging about this and talking about this for 10 years. So we have now different methodologies to be able to define, given a force bond, in this case I pick up an oil company bond, similar bond, this is completely done by the machine. So here you can use cluster analysis, you can use gradient boosting tree, you can use neural network, and again, if you use neural network, you're going to have an interpretability problem, but we are very happy about this. And now you see that two total bonds are very similar. If you start to do some trading activity on the first one, when you go to make trade on the second one, you're going to have a different liquidity profile. And so we are basically defining this similarity based on how the security are highly connected or not. There is a model we are implementing about this. So in the security similarity, we have a distance-based matrix that is done. We are testing using gradient boosted trees. And next, we're going to have a semi-supervised variational autoencoders and potentially knowledge graph. I do believe that the knowledge graph concept, I don't know yet, will be the answer in terms of methodology tool to do this job. Again, to honor my guest is about interpretability. In this case, interpretability becomes much more important than other cases because this will be used widely, technically, even for portfolio construction. Many papers we are investigating, but these two papers are done by Google people. I think it's DeepMind people, I think. So this is basically what we are doing in the lab now. The title here is Redemption at Risk, the beginning of our artificial neural network and cloud adventure. Because if you think about regressive models, random forest, based on now a lot of data, but not petabyte of data, you can work in internal infrastructure and databases. Random forest was a difficult problem, so immediately we start to end in some performance issues. Then we open a personal account on the Google Cloud, literally. The first one was a personal account. We start to make experiment, then we open a corporate account on that. And basically, the story here, so we did this first experiment without the data, just to understand how the cloud was working. Then we got approval to upload some of our data in the cloud, officially, as a company contract, and we were able to do this experiment. Using an embarrassing amount of factors, because running the redemption of the fund is a crazy amount of factors, using 3 ensembles to filter the features, and then feeding our networks. And the model we are building is trying to forecast a CDF that we can transform in a PDF. It's telling to us the probability of, we are not forecasting the size of the redemption. I will be a very rich guy if I can do that. We are trying to forecast the probability of large flows, where large is a flow bigger than a certain threshold. So basically, you take a slice on this 3D picture, and then you use that distribution to do your forecast. It's a distribution conditional to all the input factors. This is the only way we could have some decent performance in this model. Not crazy big, but good performance, something that you can use in the daily life, and was the only way to do that. Now, we are working now in trying to make sense out of this model for day-to-day users because of interpretability. Another case that we are working on, I don't have to tell the people in finance here that in particular bonds trade over the counter. This data is unstructured, and there is not quantitative way to determine the currency of dealer quotes. Dealer quotes are the big source of everybody, us included. Every vendor are using, because trades are very rare and sparse. The information from dealer are what people use to price these bonds. And as you saw before, 3 different providers, 30 years in the market, they have a severe disagreement of an easy bond. Okay? There is no way to determine which one is better or not. A lot we have to rely to subjective expertise of the traders. And the reason I joined BlackRock, because I was in a company where there was a big trading desk because of the amount of work the company has. So I was learning a lot. I thought to be an expert in pricing bond, and then given the right price to estimate liquidity. I realized no. And I learned a lot from our traders. So now, how we transform this know-how, we automatize and industrialize this know-how. So you should remember the benchmark price problem, no? And then what we are trying to do here is basically collect and weight different pricing sources, and learning how to weight this from feedback that we receive from our traders in a UI, and trying to apply NLP to their comments. So literally, when they disagree on the price, they tell to us in English why, hopefully in English better than my one. And then with NLP, we try to extract features to adjust our model. We are at the beginning of this journey, but this is cool stuff. Was an idea in internal BlackRock hackathon of 2 of my guys last year, and now we are trying to make this a reality. This is just to introduce what I think, the same final answer that I mentioned yesterday in the AI Spotlight, where I see the biggest improvements, impact of machine learning in finance. Something that I'm not expert, so maybe I'm shooting myself and keeping me out of the job, that is NLP. I'm a user on NLP. I'm not building models in NLP. But if you think what is finance is collecting data from the market, collecting information from the provider, and try to do what? To forecast people behavior. So there is the assumption that a volume published in the market, a trade that happened in a stock exchange, a rating, the fact that the bond is this sector or not this sector, is something that will enable you to forecast behavior of the market. Why don't you go at the source when you see people talking about the market? So doing NLP on textual news.
Good afternoon. The expo floor will be closing in 15 minutes.
Okay.
Please make your way to the escalators and main lobby. Thank you.
Thank you. Okay, so basically, guys, if you want me to stop, you could have a less violent way to stop me, no? I see the time here, so it was fine. Anyway, so before they call security and kick me out, so this is the application in the market, some of them in BlackRock, of application on NLP. So people using NLP to apply NLP to the transcription of the company conference call. Identify less obvious linkage between stocks, the similarity. Text-based industry classification. And the last one, what I think is going to be a dramatic revolutionary input in my modeling, new sentiment index for liquidity. So somebody doing this engine to scrap textual news, telling to me which is the sentiment on liquidity. I'm pretty sure, I have no proof on this, I'm pretty sure that this feature will drive the vast majority of the performance of the model. No, so far, nobody was able to produce for me a very high quality and a sentiment on liquidity, but the technology and the people are evolving, and I have a big hope for NLP. So to conclude, then I leave 7, 8, 6 minutes to Q&A. This is recapping. Our head of risk likes a lot this picture with the cyborg man, the robot machine shaking the hands of the human being. That's exactly the concept of pushing for innovation. BlackRock is as well as a big technology culture. It's always been pushing for innovation. I'm getting bored if I don't play with some fancy tools. So we push for innovation, but in a non-reckless way, because we have the problem of the fiduciary role to our investors. So it's always to find the balance between performance of the model and transparency, interpretability. The model surveillance that we are observing is becoming more severe, and that is what is the hot topic for us. Clearly, the infrastructure, security, similarity, NLP, reinforcement and transfer learning are the things we think we are, and we want to investigate to see if we can seek some performance in our model. So be careful, machine learning is not the holy grail, and we want to use it only when add values. We are able to prove that there are already some cases where we are adding value. We are either in the lab. More to come. The big push will be when there will be some interpretability tools, that then you don't have any problem to go wild, deep, and try everything you want. I stop here. Okay, so it's been a pleasure. It's a long journey. First time that an Italian finished before the deadline. So note this as a big event. So thank you very much for your attention, and see you soon.